Welcome, everyone. We'll be joining the session in about 2 minutes. Please hold on. All right. Well, welcome, everyone, and thanks for joining us. I think you'll enjoy what we've got planned for the next hour. I'm Jay Berryhill, the CRO for ENG. The case study we'll be sharing today is tomorrow happening today, and it's one that leverages advanced technologies in combination with supporting VDC to deliver outstanding results around cost savings, schedule reductions, safety performance. The project involves a market-leading general contractor, market-leading BIM services provider, and a market-leading tech robotics FieldPrinter. Some of the key topics we'll be discussing will be related to the progress on the project around really the challenges and solutions, demanding customer requirements, technologies used to address those requirements, and most importantly, the results and some of the key metrics and best practices that come out of it. Now, please submit your questions in the chat. We want to make sure that we answer those at the end. If they're important or urgent, we'll try to answer them during the session. Now, let me introduce you to the team that's been actively involved in this project. Some of them have been on site. They've been monitoring the progress all along the way. So with that, I'll turn it over to Ricky.
Morning, everyone. My name is Ricky Molina. I'm the VDC director here at Alston, as well as our A+ Automation, Integration, and Management Group. We're a top-rated top 50 ENR rated contractor operating in 23 offices from coast to coast. Turn things over to Zachary, give his introduction.
Awesome. Thank you very much, Ricky. Really excited to be here with the ENG BIM team as well. I'm joining on behalf of Dusty Robotics, and we're really here to help you automate your construction layout and streamline the entire BIM field process. We're doing that by helping you ensure design integrity in the field and combining hardware, software, and services to let folks like Ricky really take their digital models and print them with a full 16th inch accuracy for the needs of any type of job, including really highly quality and highly accuracy needed projects like the one that Ricky's going to be talking about.
Hello, everyone. My name is Maria Diaz. I'm a BIM coordinator at ENG. ENG is an organization with over 500 BIM specialists focused on providing BIM solutions throughout the whole building life cycle. So with that said, I think we can begin with our presentation.
Just talking through some of the key points in our case study today. We're going to be discussing, really what was driven by the client as far as innovation for some of the client requirements and constraints on the following project. We'll go through some of the technology that was implemented and why, and some of the solutions that we came up with to really solve some complex issues. And then what some of the overall tangible outcomes were after we implemented such technology. The project and the client we'll be talking about today, they're really a AI-driven automation company that's completely changing the warehouse space. It's an industrial warehouse located in Texas, and the project today is going to be what we consider a phase 2 system. So it's a renovation inside of an existing building. Go ahead to the next slide. We'll be talking through some of the client requirements and why it was really driven to use Dusty, 3D scanning, and some of the various BIM technologies. Things like increased control on site. We had a very condensed and convoluted area to work inside the existing space while maintaining a fully operational building at the same time. So we had some challenges there. Clients' requirements of really lowering the production cost, some of the manpower needs, scheduling, and timeframes. And then some of the AI-powered robotic automation that they deal with, very complex, very precise, and really some of the old and traditional methods of layout and installation just weren't going to cut it. And you'll see us talk through some of the technology that was implemented. Go ahead, next slide. And some of the challenges that were faced, some of the underutilized tools and tools that we were able to utilize, precision discrepancies when dealing with installation in the field versus design, information loss that's common on a lot of projects across the country, filtering information from the field to the office and vice versa. And then going through some of the manual checks, QA, QC process that our team had to do on site as well. And then I'll turn things over to Maria, and she'll go through the first section, which is the underutilized tools.
Okay, well, our first challenge was basically that our client was producing on the design phase a lot of information, great information, like the 3D model you'll see on the screen, and they were utilizing very automated and great tools like Autodesk Construction Cloud. However, when getting to the construction phase, previous GCs remain using the traditional methods and traditional tools, which make it like the whole tool potential remain on tap, and it was impacting the project efficiency. Now, Ricky will walk you through the second challenge.
One of the big drivers on this project was the precision needed for installation. Across this client system, we only had about a 1/16 of an inch at most times of accuracy and need. So a very high level and precise system required a very high level of installation. So those were some of our challenges as we looked at ways in increasing layout in the field, both from our installers and as well as our layout that we'll talk about with Dusty later on in this presentation. Next slide.
Then our third challenge was the information loss of project progress. Basically, in here you can see the workflow on how the weekly report was produced. The first day, all the subcontractors went to the construction and produced a report. On the second day, they sent it to the PM, and in the final day, we present the weekly report to our client and the whole and all the stakeholders. The three main issues in here is that our client was receiving the reports outdated because it was always from 2 days before. Our second challenge was that there was a human interpretation involved in the weekly report, so there was a risk that the information was incorrect. And finally, our client was losing control because they were dependent on others to know what was happening on site. And our final challenge was the manual quality checks. So all the QA team needed to make these whole checks, but the tolerance and the precision, as Ricky and Zach already told you, they were over a 1/16 of an inch. For example, in here in the image, you are seeing these blue frames, and in these blue frames, they were installed in rails. In these rails, our client designed an amazing system, and these robots move up to 25 miles per hour. But in order for those robots to move in that, this rail needed to hit one rail in front of another. They couldn't be, and the offset couldn't be more than 1/16 of an inch. So this construction was requiring high quality checks, but the methods we were using to check this remained traditional. So it was costing us time.
And we're going to walk you through some of the solutions now that this project and some of the requirements really required. We'll go over some of the underutilized tools and how we came up with a common data environment utilizing ACC as kind of our repository of information and being able to share and push information to the field. Some of the regarding precision discrepancies, how we leveraged and utilized Dusty robotics for high precision and precise layout on the slab of the entire system. And then we'll go over HoloBuilder, our 360 reality capture method, and how we utilize the latest high resolution 360-degree photos to really push as-built and progress tracking in the field and being able to push that information to the stakeholders, the project team, and really everyone involved, so they knew exactly what was going on out in the field. And then some of the manual quality checks that later leveraged the use of 3D scanning, terrestrial scanning for various aspects of the system, and how we leverage point clouds to verify installation in the field. Next slide. And then Maria will walk you through the establishment of the CDE.
Well, the first thing we did was basically setting the foundations and create a space, as Ricky mentioned, Autodesk Construction Cloud to save all the things we wanted to do. So we organized it, we create a BIM execution plan and put everything up there. Then we went back to the design phase and look for what information are we losing from the design phase. And we find out that the installation drawings were produced with Revit models, and not only Revit models, they were LOD 400. So they were incredibly rich in information. So the first way we use it to reduce time on the construction, it was related to the supply chain. So in here you can see the BOM we produce, and we produce a BOM break by construction phases because the supply and material team needed to move from the laydown yard to the inside of the construction, the amount of material they will need for each construction phase. However, because they have a complete BOM, they didn't know how much material they needed to move by phase. So we took the Revit models, break it by construction phase, and produced this BOM. And this column in here, the number 11, is the construction phase this material was assigned. So there was a huge improvement on time with the team. The second thing we did with the Revit models, we saw the potential to run a clash detection, but in order to do that, we need first to model electrical and fire, which were the two traits that remaining on 2D drawings. So ENG took those drawings, put everything together in a Revit model, and now we were able to run a clash detection. We found huge issues, like for example the one you can see in here, a conveyor clashing with the steel structure, or for example some fire pipe going through the warehouse column. So this also was an improvement on time on the construction. And finally, with Autodesk Construction Cloud, we specifically use the build model, which allowed us to create forms for the QA team. So the QA team also was losing a lot of time on creating their checks because they're making their checks on Word and spreadsheets. So they have to update it like manually, and they were spending more time on the trailer than actually on the construction checking things. So we produce, as the image on the right shows, we produce these standardized forms that allow the QA people to go on site with the iPad to do the checks and spend more time on the construction than before.
Awesome.
Now, yeah.
Thank you so much, Maria. And what's really fun about this is after all of that amazing design work is where Ricky and his team and the owner brought in Dusty Robotics. And one of the big things that we were brought on to do that Ricky will talk about in a lot of detail is making it so that what you see in those models is directly reflected in what actually gets built. And we were providing the team through our FieldPrinter platform the ability to be completely confident that we had 100% accuracy of what needed to be built by which people from which part of the model at which point in the design process. And that helped drive down rework and helped drive down any issues of, okay, what actually needs to happen at this stage of the process. And it helped the Alston project owner that we've been talking about here really have a deeper collaboration with both the Alston team and the other trades on the project to understand, okay, is this exactly what needs to happen when and where? And those two things between the higher quality and the collaboration directly led to some really impressive results related to schedule compression and just doing the job with fewer total labor hours that we see across basically all of our customers. And one way that we see that on the next slide is transforming this from a world where I'm going to mark just simple points on the ground or simple lines on the ground to a world where the ENG BIM team and the Alston team can work with the owner and say, I want to be more creative here and say everything in my model can be printed, whether that's text labels, details about what specific points are, curves, specific markings about what parts of the system need to be installed where. And that empowers the team to be a lot more efficient, not just in layout, but in actual construction as well. Before I hand it back to Ricky, I want to remind everyone, we're glad to take breaks for questions as we go, and we're glad to take any of your questions at the end as well. We're planning to leave plenty of time. So please just use the LinkedIn chat feature and add whatever questions, comments, and so on you want. And we are really excited to hear from you. With that, I will turn it back to Ricky to talk about how that goes from theoretical to real.
Thanks for the intro, Zach. Yeah, definitely. Like I said, one of the big push for utilizing Dusty and kind of an automated field printer on this project was really the client's requirement for a precise installation, 1/16 of an inch across the entire site. So by utilizing this technology, Marie and the team at ENG, we basically compiled all of the applicable Revit models, and we were able to extract all the necessary layout information on the slab in a DWG format. So I want to talk about how things were being done traditionally prior to the utilization of Dusty. You're going to see two charts on the right-hand side. On the left-hand side, we have traditional methods, and this is information we gathered through the subcontractors, through the installers, through talking with the client on past projects. This was kind of the data that was gathered. So on prior sites to ours, it was taking roughly 15 days to lay out the entire system, and it was taking a total of 4 people to do that work. So we're talking traditional methods like you normally would: chalk line, string line, tape measure, and you can imagine the accuracy that was lost in doing it the traditional methods. And then just the line work, the overall line work that was captured, and then about the information that was able to be translated on the slab. So prior to Dusty, there was really just anchor bolts. The anchor bolts for the base plates were marked out, some of the baselines for the equipment, and the mezzanine columns. Now, really leveraging that the client's data-rich Revit models, we're able to extract, a whole lot more of information, so we can be able to print it on the slab. So utilizing Dusty, we're able to go out there with a single operator and lay out the entire system in roughly 5 days. So it's a huge time savings and as well as manpower savings. We were able to print more line work on the slab. You see an increase in about 20% there. And we're able to include everything that really encompassed their system. So not only the anchor bolts and base plates, the equipment, but we started incorporating things like the pits and pads, depressed pits and pads. We had, robot base plates, IDF cabinets, We started incorporating electrical components, electrical and pneumatic drops, floor elevation, 0 points, electrical panels, ACP panels. There was a whole plethora of information that was encompassed in our layout file. And we were able to print all of that, like I said, in roughly 5 days. So our install teams out on site, they weren't having to pull a tape. They weren't having to double check measurements. Everything was transposed and ready for them by the time they mobilized. So huge time savings, both from a schedule standpoint and from a manpower standpoint. Go to the next slide, Maria. And just to recap on some of that savings again versus the traditional methods, we're talking about adding, 15. I would say that's understated, but we have a lot more information in the Dusty file that we were able to capture. 1/3 of the time spent on site with a single operator, and then all of this while maintaining that 1/16 of an inch needed precision on site. So it was a huge win for our team, and definitely a great partnership with Dusty to really be able to push this innovation out on site. And our client was a big proponent of this technology too, as they're really huge into robotics and AI. It was a partnership that was made really for this project site. Go to the next slide.
Okay, so our third solution, and related to the information loss in the weekly report, is related with HoloBuilder. HoloBuilder is a platform we implemented because we wanted to capture the weekly progress of the construction. However, we want to do it. We needed to do it faster and with more precision and showing more information. So HoloBuilder is this platform. You can save all your construction record, but the key in HoloBuilder is that they make it with 360 images, as you can see in the image on the screen. These are 4 images from the same point at different times of the project. So we were able to capture the past. We were doing like weekly walks, so we have basically the whole project on photos, and you can manage, like, you can go through the photos like a street view. You can move it and go around the whole construction. And finally, the last great thing about HoloBuilder is that you can also link your coordination file that we already made it for the BIM coordination. So we link it in, so all the stakeholders were able to see what was happening on the future, at the present, and at the past. And we were doing all of this using only 2 hours against the traditional methods. They used to use 10 hours, and we did it only with 1 person against the 4 people they were required to produce the weekly report. So in time saving, it was a huge impact on the project. And also we gave the client back the power to see what was happening on the site, and they didn't require for us to go and see what was happening. They could log in on the web page and see what was happening. And also a great thing of this is that the equipment is really small. You only need this camera, 360 camera, a selfie stick, and your cell phone. That's it. So it was faster, easier, and it was giving a huge amount of information.
Hey, Zach, we have a question that came across for Dusty. It says, other than the laser tracker and the iPad, what other tools do you need to work with Dusty?
I love that question, and Ricky may want to add a little bit to it as well, but we really try to make this as easy as possible. We're providing a laser tracker that tells you where the robot is in space and helps understand what has to happen. We're providing an iPad that has a full view of your model and lets you select exactly what layers, what points, what line styles you want to print directly in the field. Obviously, the robot itself with ink and easy field swappable batteries, and then a web portal that lets the ENG BIM team or anyone else who's working really directly connect the model and the elements that need to be printed in a very easy to use way, so that it's all one seamless solution to go from your model directly onto your printing on the slab.
Yeah, and to add to Zachary's point too, from the operator standpoint, it was very easy to use. There's a little back end work, getting the file up to speed, grabbing the correct Revit models, utilizing ENG to really prep that work for the iPad. And then other than that, from the GC standpoint, it was having a surveyor go out to the site and set pucks and control on the columns so the unit could orient itself. But there's also other means and methods for that as well. But very, very easy solution to work with. And yeah, support is excellent all along the way as well.
Glad to
Yes.
hear it, Ricky. I think we should probably take one more question there, that someone asked something on a very similar vein from Rodrigo, which was, did the layout creation for Dusty require a lot of effort to produce it? Maria, I think you worked on that, right?
Yes.
You want to talk about that one for a sec?
Yes. Actually, it was pretty easy. So, of course, it was something new, and we need to have a previous training with Dusty. Dusty will provide us the training, but after that, we have been creating over like 15 files maybe this year for Dusty with the ENG team, and you only need AutoCAD, Autodesk point layout, the plugin, and the Dusty portal. That's it. So it was actually pretty easy. Yeah, after you got the training, there's nothing very hard to do, and also understanding the clients now that way we understand what the client wants. Well, is it's made us for us easier to go all over the requirements and the production of the file.
Awesome. Thank you.
And then the next innovation or approach that we took out on site was really through the use of terrestrial scanning, 3D scanning. Like I said, with the high precision of the system, there's a lot of equipment and machines and robotics on the front end. As you can imagine, we have these depressed pits, for example, that we're sharing up on the screen now, that had to have, in the past, there was a lot of manual checks related to proper depth, slope, width, length, things like that. So the traditional methods of checking it was roughly 4 days with 2 people, traditionally with a tape measure and checking all the depth. A lot of, as you can imagine, a lot of information would have been lost. So having our A+ team out there, our automation and integration and management team, we have a team that's dedicated to 3D scanning. So we were able to mobilize one operator to the site to capture all of the pits and pad location in one shot. So a little bit of time savings, because you do have the faster field capture, but you do have about a couple days of working in the office as well. But we were able to shave down the manpower to, by 50% by only utilizing one person. And then go to the next slide, Maria. I just want to talk about kind of what was captured. So the client originally had kind of their traditional means and methods of checking the pits in these locations in red to the left. So you can see, there's a lot of data that would have been missed. You're not capturing the entire depth of the pit. There's areas of the pit that aren't measured, things like that. So it was a pretty simplistic form, and I just knew that through the use of 3D scanning, we were able to get a more comprehensive report that would capture all of the dimensions within, 1 millimeter of tolerance. So to the right is kind of our form that we had created and shared with the client that they ended up really, really liking. Not only are we able to get a complete floor map or a heat map, getting every point and elevation, but we're able to dimensionally check it back to the Revit file as well in regards to depth and dimension. So one shot out there, one operator, bring that information back into the office and be able to verify every pit very precisely and with a high degree of accuracy as well. So huge time savings, and then also just being able to document it from a QA QC standpoint was very helpful. And then kind of wrapping things up here before we get to Q&A, just some of the lessons learned from us and our team out there. From the implementation of the common data environment, we were able to push a lot more trade coordination meetings. We were leading and facilitating BIM with our installers and contractors out on site. So roughly 11 coordination meetings. We had about 60 large issues, many of those issues resulting in design R5s or at least, direction from a engineer record to verify or quantify something for us. So that was helpful. And then working with our A plus material management group on the BOM spreadsheet. So we were in charge of basically checking out material, tracking material. We were able to leverage the information, the data rich information in Revit and break it down into spreadsheets that Marie had described before with areas, zones, levels, and then exactly where and what that equipment was. It's a huge organizational tool and was able to really, spearhead the project. And then leveraging Dusty Robotics, huge time savings that we had discussed. Currently, right now, we're on 4 additional projects with this client. So we've been utilizing the technology across other sites, both small and large. We got the contract to do Dusty layout preparation for all of their projects. So we're doing a lot of that back of house file preparation for the iPad and the Dusty solution. And then to date, we've laid out more than 3 million square feet of layout on the slab. And then with Hollow Builder, capturing those sites weekly, sometimes a couple times a week, a whole plethora of high resolution photos that we've been sharing with the team and stakeholders and everyone involved. It's been a huge technology to be able to track progress in the field. And then the discrepancy reports, leveraging the latest technology through the use of 3D scanning, improving our reporting, accuracy of reporting, and the totality of our QA QC division. So being able to verify the 16th of an inch and track any discrepancies across the site. With that said, we'll kind of open it up for some Q&A at the end. Feel free to leave your comments and we'll try to go through them. Thank you.
Hey, Ricky, I think this one might be for you too. This has come in. What partnerships do you need with both your trade and owner to make this project successful? What was the owner trying to do?
That's a great question, Jay. I think first and foremost, everyone kind of needs to be on the same playbook. For us, it was pretty easy. Our clients really leading the charge in innovation with their system. They had come to us wanting solutions that would both, save time on the schedule as well as costs. So that was kind of easy for us, and then it was on us, on our due diligence to really find the technology that would apply, that would meet the client's requirements, that would be able to check those boxes for them. So, and then filtering down, in order to be successful in any of these projects, we need to have a good relationship and understanding with our subcontractors and the installers. Everyone has to trust the process. Everyone's engaged in the process and they trust the technology. So it was a lot of learning curve for a lot of folks out there. But I think when they saw some of the powerful tools that were being implemented and we weren't taking, there's this perception with new technology that we're taking people's jobs away. And that couldn't be further from the truth. We're really empowering them to build more work faster and cheaper. So that was really the push for Dusty and some of these other technologies out there, is we're able to shave down time on our schedule so that they can get to their job and get to installing the system quicker and with high precision.
Very good. See, another one's come in. Let's see. Wow. And I think this would go to you, Maria. What did you do differently in your normal BIM management processes to make this happen?
Actually, it's just we did the same as we always did. Like, as Ricky tell you, sometimes it's scary facing new technologies, but we are a BIM services company, and we're used to trying new things. So it was just learning how to do it, incorporate it to our workflow, and right now everything's running smoothly.
I love that answer from Maria. And I'd say that's always been one of our goals at Dusty as a company as well, is change management is always one of the hardest parts of any construction project. And our goal is to say, how do we make this as successful as possible within existing workflows and processes wherever possible?
Hey, Zach, another one came in for Dusty. It says, let's see, what is that? When printing with Dusty, what happens when you encounter inaccessible zones or obstacles that could interfere with the robot?
Love that question from Nicholas there. The first answer is we really pride ourselves on being able to print up to 3/4 of an inch away from any obstacles. So you can print pretty close to stub ups, to walls, and the like. And if there's an actual physical obstacle in the way, it will mark that part of the line or that part of the layout as unprintable. And you can either go back and offset the line. So I can say, I want to mark that the line is actually 3 inches that way for one section, or you can try moving the obstacle, of course, and you have all of that data in your reporting, in your analytics, so it's always really clear what we got laid out, what we didn't, and what needs to happen. And we can also print directly behind small obstacles or small stub ups, so you don't need to have anything other than a broom swept floor, and we know that job sites are messy places that have things going on.
I will also like to add that the pre-existing obstacles like columns or walls, ENG produce when they produce the file, we put it as obstacles, so the robot already know he cannot go through the element. So that's another way of ignoring and not clashing with the existing columns or elements.
Spot on. And that especially matters on complicated job sites like this one, where we already have a bunch of production lines going and we're working around those. You're going to have things there, and you can mark in your file for layout, I want you to navigate around this area. I want you to not go here. And that's really important for all of our customers, but especially for this job. Ricky, anything to add there?
No, I was just going to say, from an operator standpoint, the iPad and the solution makes it simple to mark out obstacles. I mean, we all know that a job site isn't a perfect site. There's material in the way, there's lifts, there's people walking. You have to think on the fly and adjust your plan. So Dusty definitely makes it easy to adjust and move around things and get the layout ultimately completed.
This is an interesting one that just came in. Did the subcontractors have confidence working with the Dusty layout, or did they oppose it? And I don't know, Maria and Ricky, if that's to you. I know Zach will give an answer, but
let's start with Ricky on that.
No, just kind of shadowing what I had said previously. I think with any new technology, it's scary for people to fully rely on it. And like with anything, the contractors that we have out there, the installers, they've had some experience in the past working with Dusty, so that was definitely helpful. Not everyone was green out on site, but I think there's some hesitation. There's always some good hesitation with it until they actually see the results. I know a lot of the time our field operator, he was getting back checked by traditional methods. Everyone wanted to doubt this and that, and they would pull, tape measures and the stuff was right on. It was, there was no time that it was off. And I think that really gave people some confidence in the layout, and we're able to trust the layout going forward. But it's healthy to always have questions. I wouldn't blindly trust anything technology related. You definitely have to have your hands on it, see it in the real world in action. But I think when you see the results, they really speak for themselves. And over time, it was something that was well trusted by our installers.
I'll add to that what Ricky just described happens on almost every job site that I've had exposure to, where there's going to be someone on a trade who's involved who says, I don't know if I trust this. I don't want to stake my build on it. And is going to follow behind with a chalk box and a tape measure and double checking things for the first like day of layout. And then they're going to say, wait, I didn't actually find anything yet. I've been on my hands and knees spot checking this for 4 hours of a shift. I guess it's working. And that's totally fine if that's what a subcontractor needs to feel that I have the confidence that I can build based on this. That's a good use of that half day for that foreman to check. And then everyone's like, okay, I'm comfortable, I'm confident, and we're going to go with the 100% accuracy of the system.
I will also like to add that I'll still have this great idea of having a ENG person on site to support this. So in this project, it was me. So whenever the subcontractor have a question or they wanted to review something, I was always on the side, and I showed them like and confirmed them that what was happening on the side was right. And over time, well, those confirmation were less and less, and well, they trusted.
Hey, a question came in around Hollow Builder, and is the analysis of the data captured by Hollow Builder how is the analysis of the data captured by Hollow Builder conducted? Does it produce reports compatible with Navisworks or something similar? Or how do you check for collisions or problems that may arise day to day based on those reports? I guess Maria, you would take that. Or Rick.
Yeah, like how to we are able to produce reports of weekly progress. So there's a option on Hollow Builder, so you can download a report. The report have all the images and the links to the Hollow Builder site, but Hollow Builder itself does not show you the clash detection. It is only a tool to see the progress and compare what's happening on site and with the coordination report.
Just to add to that, there is some visibility tools and plugins with Navisworks. So I know Maria had worked on bringing in our coordination model so that we can view exactly what's being installed in the field versus the design model. So there's some visualization checks that we're able to utilize inside Hollow Builder but for the majority of our hard clashes and conflicts, we're utilizing Navisworks for that.
Okay.
Looks like we have a question from Fanny in here that I actually don't know the answer to. How long did this entire project take end to end?
It was about 9 months. But the goal from the client long term is hopefully get these down to like 4 months, 3 months, 4 months. So there's really a drive from them from an innovation standpoint of finding faster and more efficient ways to build. So we're definitely exploring that with our A+ team at Alston. It's a constant work in progress.
Yeah, I think also that we have seen with Ricky that we have compared like at what time of the project we detect the issues, and we're seeing that now in these new projects we're doing this year, we are detecting and more or less the issues 4 months earlier than previously. So this is helping us, like we're learning from the past. So this is also impacting the time.
Great. Obviously, a lot of new technology that produced results that are pretty amazing. With taking some innovative approaches. Ricky, kind of to wrap it up, what would advice you give to your peers, others in the industry about using new technology like Dusty and Holder Builder and working with clients and with partners like E&G?
It could be pretty long-winded, but no, to keep it short, it's really the way the industry is going. We're seeing more BIM requirements on our scopes of work, on our contracts. It's being pushed from our clients and owners as a requirement. So a lot of this is client and owner driven. But at the same time, a lot of these projects, as many of you who've called in know a lot of these projects are getting more condensed. Things are getting expedited. People are looking for ways to save money. Interest rates are high and all that. It becomes an important role in, being able to shave time off a schedule, being able to minimize cost, and then eliminating rework and waste on a lot of projects across the country. So it becomes an important part. I know at Alston, it's an integral part of our drive to push innovation. We're utilizing a lot of this tech and resources across our projects across the U.S. So it's become a very impactful and insightful way we build, and it becomes important to our clients as well. It's a selling point. It's a service that we provide, and it's I could go on and on about it, Jay, but it's that's what I would recommend, and that's what I would say to some of the others looking at investing in technology, or at least it's a scary step like anything, but I think the benefits and the accuracy and some of the time savings that you end up having on the back end really pay for itself.
Well, great. And congratulations to everyone involved in the project. It's you guys, the results are fantastic. The metrics, the best practices, certainly something that now is repeatable process, and, looking forward to the next results out of it. Thanks everyone for joining. Look out for the next E&G webinar. They'll be held at the end of August, and I appreciate everyone joining for the 45 minutes here, and see you next month.
Appreciate everyone. Thank you.
Thank you.